I'm good. How are you?
Good. So, we still doing logs? Hello? Feels like I lost audio for a second there. Can you hear me, Mina? Mina, can you hear me?
Yeah, I can hear you.
Oh, okay, cool. Here, let me turn off some of my other applications. That might help a little bit. All right, so what do we got tonight?
There are a lot more logs. So, for example,
Boy, the audio is choppy. Didn't hear what you just said.
log base b of x minus log base b of y equals log base over log base b of y.
What was the right side of that equation?
Log base b of x over log base b of y.
Like that? Because that's not right.
Yeah.
In other words, if I apply the rules of logarithms, that turns into the log base b of x over y. And that's not the same as that.
Oh, it's a true or false question.
What? Oh, it's a true
or false
question. Okay, this is false. You know what? Let me do the audio a different way here. If you don't mind, I think I can improve upon our audio. Do you have a speakerphone that I can call back?
No.
No, you can't use your cell phone as a speakerphone?
Oh, I could do that.
What's that?
I could do that.
Let's try that and see if it improves. The only reason is the audio is so choppy here that I'm not sure that I'm going to be able to figure out what you're saying. Let me try, should I call this 8936 number?
Yeah.
All right.
Right.
Did that improve the audio for you?
Yeah, kind of.
Yeah, it definitely did for me. All right, what's the next problem you have?
Find all values of x satisfying the equation natural log, parentheses, natural log, parentheses, natural log x, parentheses, parentheses equals 3.
Like this?
Well, no.
Tell me how to write it again. I got lost in all those parentheses.
Natural log, parentheses, natural log, parentheses, natural log
equals 3.
Yeah.
So there's a parentheses there, and then another one there, and then a, no, I guess that's all, huh?
Yeah, and then equals 3.
Okay. Let's do this one step at a time. Starting from the outside, going in, let's convert this to an exponential expression. What's the first?
E. E. Or
E to
E.
the third. In other words, the number on the far left raised to the power on the right. E arguments. So this argument is natural log of x. So that's the first thing I can write. You with me?
Yeah.
See how I got that?
Yeah.
Okay, now I'm going to do it again. E raised to the e to the third power must equal natural log of x.
Also, we do it again, so the E to the E of third power equals x.
E to the e to the e to the third power equals x. Now, that must mean parentheses there, and parentheses there. In other words, the way we would get this number on a calculator would be figuring out what e to the third power is. Let's say e to the third power is 10. Okay? So now it would be e to the to the 10th. Now we have e to the 10th is 1,000. Well, then the final answer is e to 1,000. Interesting, because almost every other algebra problem you do when you have a bunch of nested parentheses like this. So this is a bit unusual. I suppose it's because it's logarithms, which are inverse functions. And that's why we work from the outside in. Okay.
Mm-hmm. True or false, x to the fourth power equals x to the fourth of x power.
Power equals x to the what?
No, x to the x to 4 power
X to the x
to the 4 equals x to the fourth x power.
Are there any parentheses anywhere?
No. So just 4x, not 4 to the x, just 4x.
Uh-oh. Yeah, that's true. let's talk about that. I'm not totally sure. If I said 2 to the third power raised to the fourth power, that's definitely the same as 2. When you do a double exponentiation, you multiply the exponents. However, if I take away that exponent or those parentheses, then I believe the way this is evaluated is you do 3 to the fourth power, which is 81, so that would be 2 to the 81 power. Not 100% sure. I guess we could do an example. Let's do something with smaller numbers here. I'm not even sure. Let's do that one. I'll see what our calculator gives us. Because I know that that should be, if I put parentheses around it, then that's 2 to the 6th, which is 64. Okay, so I know what that number is. That's 4 cubed, which is 64. Okay? Mm-hmm. Now let's try it in our calculator where we don't put parentheses. We just put 2 raised to the 2 raised to the 3. Let's see if we get 64. Yeah, we do. Even if we don't put parentheses. Therefore, I guess without the parentheses, it doesn't matter. That's still true. X to the x to the 4th is equal to x to the 4x. The same way that that is equal to 2 to the 6th. Typically, you never see it written like this. You always see it with parentheses. So I would think, and I don't suppose it matters whether the parentheses goes there or, I guess it does matter. Yeah, okay, so it's very important where the parentheses are. In other words, if I said this, if I put the parentheses there, well, now I have to do the exponentiation first. 2 to the third power is 8. That would be equal to 2 to the 8th. So it's all to the 6th if I put either the parentheses around there. Your problem has no parentheses at all, right?
Yeah.
Which makes it ambiguous. I'm going to say true, but I'm not 100% sure. It's the reason you should always use parentheses in case you're not sure, so that you can clarify things like that problem. According to the calculator, if you do a double exponentiation, it acts like the first 2 terms are in parentheses. But if I went on to Wolfram Alpha and did that same thing, I'm not sure I'd get the same answer. Not sure that if I went 2 to the 2 power to the 3 power, whether I'd still get 64. Okay, what else?
Log base 5 of 125 equals log base 2, 64, divided by log base 7, 49.
Okay, the easiest way to solve this is let's put numbers on all of it. What number is that equal to?
3.
What number is that equal to?
6.
And what number is that equal to?
2.
True statement.
Can I quickly email you this problem?
Sure. Send the template that's for you, just in case you had my other email in your phone.
Wait, which email?
I'll write it. Send it to this, which I'll get right away. You send it to my other email, it's forwarded to this, and I don't always get it immediately. The caps don't matter.
Did you get it?
Okay. So the amount of bacteria in the petri dish is equal to the starting amount okay?
Mm-hmm.
So we can substitute everything we know. The amount 6 hours later was 450. Starting amount was 100. R is the unknown, and T is 6. So, and the reason T is 6 hours as opposed to 6/24 of a day, the hourly growth rate. They don't want the daily growth rate, they want the hourly growth rate. So we have to solve this equation. There's only one variable in that equation. That's R. If we solve for R, we will have the answer. What's the first step for solving this?
Divide 100 on both sides?
Okay, so now I got 4.5 equals e to the r 6r. Next step?
Take the natural log on both sides.
What's the right side turn into?
6R.
Left side is natural log of 4.5. So r is natural log of 4.5 divided by 6. Whatever number that is. Probably worth. Do you have a calculator in front of you?
No, not today.
The only thing that would be worth taking this further, I mean, I know that you probably have to come up with a numerical answer, and I'll leave that up to you. We've done the hard part. But it would be maybe worth knowing or checking whether that was a plus or minus number. If this is negative, then we've made a mistake somewhere. Obviously, R cannot be a negative number. But I know this is positive because it's base E, which is 2.7. So that has to be raised to a positive exponent in order to get 4.5. further, and in fact, that's a perfectly satisfactory answer, as opposed to a decimal. Unless the teacher specifically says, give me a decimal answer rounded to the nearest hundreds, the best answer you can give is that right there. That's the most precise. No wonder that email got to me so fast. There was no graph, no picture or anything. It's just text. I was surprised I got it so quickly. What else?
Okay. So, use the rules of logarithms to expand and simplify the expression.
Okay.
Log base 4, parentheses, x cubed, square root of 4x plus 1 over 64 x, well, parentheses x plus 2 to the 4th power.
Like that?
Yeah.
Exactly like that?
Yeah.
Okay. Take it apart one piece at a time. But before we even take it apart, let's get rid of the radical sign. Let's make that 4x plus 1 to the 1/2 power. Okay?
Mm-hmm.
All right. So, let's start separating. First term we're going to have is log base cubed. What's next?
Minus,
So let's do the other product
Oh,
that's
wait.
in the numerator.
4x.
Let's do plus.
plus 4x
Plus log base 4 of 4x plus 1 to the 1/2. Now we can do minuses.
log base 4 of 64 x plus 2 to the 4th.
Minus the log base 4 of x plus 2 to the 4th. Notice that every product becomes an addition, and every division becomes a minus. Now, we haven't fully expanded it because we can still take these exponents. In other words, the next line is 3 log base 4 of x plus 1/2 log base 4 of 4x plus 1 minus, what is log base 4 of 64 equal to?
3
Minus, bring the exponent down in front, so that's fully expanded. In fact, I don't even know that we need to turn that in. I guess we do need to turn that into a 3. In other words, everything else still has a variable in the argument, so we can't simplify it any further. But we can definitely simplify that to a 3. Now, in terms of the signs, I could have done this by putting a parentheses there and a plus there. the log of A plus the log of B minus the log of X minus the log of Y. Okay?
Mm-hmm.
You saw I did this last step, right?
Yeah.
All right, unfortunately I have it 7:30, so if you have a quick problem, we can do it.
All the problems I have take a while.
Okay, those are probably out. So I guess we'll have to call it a session.
Okay. Thank you.